Chapter 2 is really a fun chapter because there are a lot of cool applications like for fluids and fluid flow and pressure. It's also really important for the human body because, of course, the human body has a lot of fluids in it. And so in order to understand how those fluids move about the human body or how they operate within the body, it's very important to understand the physics behind fluids and pressure. So to begin, pressure is a force per unit area. And we'll define it as P equals F over A. Just to be clear here, so my letter P will always have this base on it. You'll see why later when we get to density, because the letter rho, which is a Greek letter, will have a very similar look to it. Um, Also here, pressure is required to move a fluid. So if I want to move a fluid from one position to another, fluids will always tend to move from low to high pressure. We see that in weather patterns, we see that in our human body. And so if you need to move a fluid, you require a pressure. And so for some applications include breathing, we'll talk about that, blood flow in the circulatory system, digestion, delivering medicine, are all topics that we'll talk about and how we use pressure to move various fluids as related to the human body. Uh, as I said, the definition is P equals F over A. Area, just as a general rule, is length times width. The area for a circle, a little bit different, is going to be pi times the radius squared. Um, or, if you're doing this on a test, you could just say that this is 3r squared, because pi is approximately equal to 3. We have lots of different units for pressure, and while there is an SI unit, the SI unit is the Pascal. The Pascal we abbreviate as as a PA, capital PA is the person's name, and it's equivalent to 1 Newton for force per square meter for area. But we have other units too that we'll see throughout, and they're all, somewhat common. Inches of mercury, also millimeters of mercury. We'll see why that is. Atmospheric pressure is measured in atmospheres. And we'll see that the pressure at sea level is 1 atmosphere. We abbreviate this ATM. And a bar is 100,000 pascals. That's 10 to the 5th pascals. And also centimeters of water. All of these, the inches, the millimeters, and the centimeters, those are all related, and we'll see what that refers to. But in short, it's going to be the height of a column of that liquid. There are 3 possible sources of pressure in a fluid, and we'll look at each of those. The first is the weight of the fluid. The second is an external force applied to the fluid. And then the third is the internal force due to the interaction of molecules. Okay, so the weight of the fluid, we'll get into more detail for each of these, but this is like the pressure at a depth. So like, a submarine going below the surface of the water experiences great pressure, and that's simply due to the weight of the fluid. Also, the atmospheric pressure is due to the weight of the atmosphere bearing down upon you. We'll see that external force applied to the fluid. A great example of this is our hydraulic systems. And we'll see what principle is applied to that and how that operates. And then finally, the internal force due to the interaction of molecules. If I have a fluid, I'll look at a liquid here. I have these molecules that are all moving around in different directions. But if I increase the temperature of that liquid, those molecules are now moving at a faster rate, and the pressure due to them moving at a faster rate will increase. We see that with the ideal gas law. If you've seen that, you probably saw it in high school chemistry or physical science.